Morning, ma'am. We're just waiting po for the host and the speakers po.
Good morning, sir. Yes po. Noted po. Thank
Opo.
you.
Meanwhile po, let's enjoy na lang the elevator music that I prepared. Sige po.
Yes, thank you.
Ma'am, morning po.
Good morning.
Morning, sir.
Good morning.
Tuloy ko na po kayong host, sir.
Sige. Thank you. Ikaw ba to, Richmond?
Yes, sir. Yung PAASE admin po.
Thanks.
We're live na rin po on YouTube, sir.
Okay.
We're waiting na po for the speakers na, sir.
Yes. Request ko na silang mag-login.
Tsaka mag-test po tayo ng
Mm.
our slides.
Okay, May, we can see your slides now. How about your audio? We can't hear you, May.
How about now?
Yeah, it's okay.
All right. All right, great, thanks.
Would you like to try your slides and audio? I would you like to try your slides and audio?
Good morning po to
Good morning.
everyone. Opo. Sir, I think I'm good with this slide sharing po.
Okay.
Thank you po.
Yes, Ma'am Lisa, please go ahead. You have permission to share po.
Liz, you can also try your audio.
Ernst,
Yes,
sorry, I just ended another meeting, so I will share my screen now.
sure, go ahead.
Check the how it goes.
Yeah.
And you're looking at my whole screen. Sorry, it will not be like this. Uh, let me just go to the. Okay. Share screen. Can you see it?
Yeah. You can show.
Okay, I'll try to do the slideshow.
Yeah. All right.
Okay.
It's good.
Thank you. Thank you so much.
Okay. Uh, good morning, everyone. Thank you very much for good morning, good evening, everyone. Thank you very much for joining the webinar this morning of the Mathematical, Statistical, and Data Science Research Cluster of PAASE. This morning, we have three distinguished speakers who will talk about the importance of empirical evidence in decision making. So without much further ado, we will start with Dr. Lisa Grace Bersales, who is currently professor of UP School of Statistics and also the vice president for planning and finance and planning, and former national statistician of Philippine Statistics Authority. Okay, Dr. Bersales.
Thank you very much, Dr. Barrios. I would like to first thank you for inviting me to today's webinar. I'm really impressed at how PAASE has, been putting out these many webinars that are really most helpful to those who are interested. And our theme for me is really timely, showing the relevance of what we do in the academia and in research to nation building. For me, that's really the bottom line. Nation building using empirical-based empirical basis. So the paper or the presentation that I decided to share with you today, and may I go to the start of my presentation. Okay, it's about a topic very close to my research interest, which is actually my main research interest, time series analysis, and using official statistics for looking at what's happening in a certain aspect of official statistics. And so I decided to use time series analysis on looking at the behavior of major industry sectors of the informal economy. what is my motivation? My motivation is really, as I've said, it's about nation building, giving proper information on certain aspects of Philippine life that, in my mind, everyone needs to know. And the pandemic, COVID-19, is really where we are now. And everybody knows this already. This has been released by the PAASE. This is the most recent estimate of the performance of the economy of the Philippines. And as you can see in this slide, in 2020, we really had a devastating effect on the economy, where there was really a deceleration. It's not just a deceleration. The growth has all the gains in the past years of economy growth was wiped out. The good news is, if we look at the trend in this graph, there seems to be some recovery of the economy as of the first quarter of 2021, though not as fast as what the government would want to do. For me, this is really something to look at, given that there is a balancing act that the government is doing with addressing economy as well as health. So lockdowns, how does the government balance the health of the citizens by making areas in quarantine with different classifications. So this, and the major industry sectors of the Philippine economy are services, industry, and agriculture. So as you can see, services of the three major sectors have declined more than the two others. Agriculture seems to be what I would call more robust, but still there is that decline. And under industry, this presentation emphasizes is the effect of the recent pandemic. I'm assuming that these are the effects of the pandemic on construction, other services, real estate, and ownership of dwellings. And so may I just go straight to informal economy. In the informal sector is referred to as household unincorporated enterprises, both informal own account enterprises and enterprises of informal employers. That's the concept that that the Philippines has officially adopted, and which is the standard all over the world. But how to actually operationalize this in the Philippines, we have what is referred to as an unorganized sector. This is sector not covered by establishment surveys of the Philippine Statistical System. So we have the ASPBI, the annual survey of Philippine business and industries, and the quarterly survey of such. And so for my presentation, when I say informal sector, I actually am using the definition of an organized sector. And this is actually estimated by the Philippine Statistics Authority quarterly, although they don't really highlight, or they don't really report this as part of their quarterly performance report on economy. And so for my presentation, the questions I wanted to be answered would be, what is the contribution of the informal economy to the total economy before and after the pandemic? And what are the co-movements of these three sectors of the informal economy? Are they moving in a similar way? Are also more technical terms would be, are they co-integrated? and are they ranger causing each other? So meaning movements of one could be explained by movements of the other. And the data, as I've said, are from PSA, specifically the Macroeconomic Account Service. And these are the GBA of both formal and informal sector, though I focus on informal. And by major industry, this would be the gross value added for agriculture, fishery, forestry, which I refer to as agri. Industry, I refer to as IND, and services, I refer to as serve. And PSA has recently rebased their GDP and system of national accounts indicators to the 2018 prices. And the scope of what I would be presenting would be Q1 to 2000 up to actually Q1 of 2021. The Q4, Q2, Q3, Q4, I did some projections which I will not show today. And so, as I've said, the methodology I'm using is a vector error correction model, which looks at co-movements of time series of the same integration order, meaning they are moving similarly, but removing the effect of spurious correlation. And the modeling that VecM does looks at both the short-term co-movements as well as the long-term movement, with some error correction in case the movement digresses from the general equilibrium in cases of shocks to any one of those time series. And so the analysis is the usual that we do for VecM, focusing on looking at the impulse response functions and the variance decomposition. So what did I see? The answer to my question, what is the contribution of the informal economy to the total economy? Looking at during pandemic, of course, during pandemic, we still have just how many 6 quarters? About 6 quarters or 5 quarters only. But we can clearly see the change or the disruption. And so this is the answer. I'm showing you like an introduction to the answer to the question. This is the movement of formal sector and informal sector of the economy. As you can see, if you look at blue, this blue, which is the formal economy, and the orange, which is informal economy, the speed of trend increase for formal economy is higher than informal, with the formal sector having Q2 and Q4 peaks. Also, sorry. Just to give you an idea on how the movements are. And the informal economy, on the other hand, has one peak, which is in Q4. So for me, there's something really of note that economic activity in the informal sector is really distinctly higher during the fourth quarter. And as you know, services, so of course you have all of the informal sector being very busy during the fourth quarter. And of course you see the disruption starting the first quarter of 2020. So this is it. What is the share of the informal economy to total economy? And so as you can see, through the years, we have in the beginning of this series I'm showing in 2015, the share is about 65%, 35% formal to informal. But through the years before the pandemic started, this has become in fourth quarter 2019, 67% to 33%. So there is a trend for the formal sector to contribute more to the total economy. However, after the pandemic started, as of the fourth quarter of 2020, it seems the share went back to 2015 level, where 64% share for formal and 35% share for informal. Basically, what this is saying is now the informal economy is taking, maybe the effect of the pandemic really is that people are now, doing their economic activity outside the formal sector. And of agri, industry, and services, you can see that industry is quite stable, although from 2019 level of 20%, it's now 21%. So this is the share of the major industries to the informal economy. So in 2000, the share is 36% of informal economy is agriculture, 21% industry, 43% services, and that the informal economy in agriculture share has gone down, but in 2020 is up 30%. But if you look at services, it's quite, I'm sorry, that's industry. Industry is 20 to 21%. Then this is agriculture, and this is services. So my message here is that agriculture sector is the share to informal economy has gone up in 2020 compared to 2029, but services still has the major share of the informal economy, services. And what are these services? They are mostly retail, rental, and land transport. So this ownership of dwellings is really the imputation of rental income if the owners own the dwelling. So it's retail. Now, what are the co-movements? This is the VECM, the model that I'm using. So the Y vector, the three series, and I will remove that constant there, but the three series that are being studied are agriculture, services, industry. Please, these are informal sector or informal economy in these three major industries. And the past values that I used are up to four quarters in the past. And I included exogenous variables to explain more the behavior. And the main exogenous variable there I consider exogenous to the system of the three series is number of employed. Then I included the dummy variable for COVID, dummy variable for quarter 2 and quarter 4, interaction between employment and quarter 2, and interaction of employment and COVID. And so doing the estimation using EBU's version 9, this is the co-integrating equation. And these are the estimates. I would just like to highlight the message of these estimates. The yellow fill are the estimated coefficients of the co-integration equation, and they represent how fast equilibrium is achieved by the specific series if it experiences shocks. So the more the estimate is near -1, the faster equilibrium is achieved. So as you can see, of the three series, agriculture is the one that is lowest in going back to equilibrium in case it experiences shock. So this is really what I would like to emphasize. The agriculture sector is a concern. It reverted to having a higher share of informal economy during the pandemic, and it has a slow return to equilibrium, meaning how it absorbs shock, mas mabagal and slower compared to services and industry. Services seem to be more faster, going back to equilibrium, and then of course industry. I hope you don't mind. Let me just go straight to my next message. The next slides here are really just to check if indeed co-integration is present among the three series, and the answer is yes. There are actually three co-integrating relations, and on Granger causality, what of the series Granger causes the other, meaning explains behavior of the other. So agriculture is Granger caused by industry, but not services. Services is Granger caused, can be explained significantly by agriculture, both agriculture and industry. Industry also may be explained significantly by agriculture and services. And so what do we see? The impulse response functions show the impact of a shock, or one standard deviation shock of each industry group to the informal industry. And so the blue one is the behavior of agriculture. An initial shock to agriculture from one standard deviation in its own series is first felt in the first period, still felt in the fourth and eighth periods. And this is, for me, not I'm showing you only up to 10 periods, but you can see there, the blue one does not just diminish. So I'm showing you only up to 10 periods, but the diminishing is felt 16 periods later. So it's like four years later. In my mind, this is really one of the illustrations of agriculture, really the effect to a shock in agriculture felt even like 4 years later. Initial shock to agriculture from in red services is felt even up to the third period, but there is more faster diminishing to zero effect, and the shock from industry to agriculture is felt up to 8 periods also, but diminishing after that. And we do the same for services. Services is something that worried me actually, because if you look at just this one, you see that the shock, one standard deviation shock of the three groups on services don't diminish after 10 periods. And I just didn't show this, but I looked at longer periods. And again, 4 years. It takes 4 years for the impact of one shock to diminish. And there's also some similar behavior for the industry effect of shocks to the three series shocks on industry. What is interesting to me is looking at variance, and we unpack the variance of each industry grouping, informal sector, by what can be explained by the others. And so for agriculture, variation is explained by shocks to itself. First initial effect of the shock is 100% is really explained by agriculture, shock to agriculture itself. But if you move to latter periods, there seems to be stabilization of what the other services could explain on agriculture, and eventually 79% of a shock to agriculture is explained by itself, 4% by industry, and 17% by services. What this message tells me is agriculture really is by itself. I mean, other services especially cannot really explain much of the variability of agriculture. Industry, only 70%. Services is different. Services, eventually, actually, the variability, the variation of industry can be explained by itself, 62%, 12% by agriculture, and then industry by 26%. For industry, it's a similar picture as agriculture. It seems it's actually industry. It's services variability that for which the other series would explain. And so moving forward, I just use employment as an exogenous variable, but if we look closely at labor force statistics, it's actually source of leading indicators to economy. So this is what would be my next. Thank you very much, Dr. Barrios, for your kind attention, everyone.
Okay, thank you very much, Dr. Bersales. Maybe we can entertain a few questions before we'll proceed with the next speaker. So we have two questions here in the chat box. First is agri covers crops, livestock, fisheries. Can you share your forecast on the effects of current pandemic on each sector?
Oh, hi, no. No, hi. Apology, I did not go beyond studying co-movements. I didn't produce forecasts from this. So I don't have any answer to your question. Sorry.
Maybe,
based on my VECM.
Maybe you can include that in your moving forward note.
Right.
Yeah.
Thank you. Actually, I did some forecasting, but using just the univariate, the error correction models from each. I didn't do it for the VECM.
Daniel, can I follow up?
Oh, yeah.
Sure.
Lisa, it will be nice if we can differentiate effects on crops, livestock, and fisheries, because that will be very useful as far as investment or the stimulus that need to be put into the agricultural sector. Okay.
Thank you. No, yeah. So actually, I started looking at the sub industries when I mentioned. So 50% of the informal economy comes from services, and so I started going there and looked at what they are. But I started just with services, and I stopped only by saying that it's more retail. And so yes, as you've seen, agriculture seems to be the effect of the pandemic is not that severe. So it's good for me to go into the details, crops, livestock, and fisheries. I know the fisheries sector is really working hard on aquaculture, filling the gap of commercial and inland fishing. Thank you for your advice. That's
Okay, thank you.
the moving forward that I will do.
Okay.
Well, I just have to caution you that you might be able to observe a lot of complicated interaction effects because of the Asian swine flu
Yeah, okay.
phenomenon, which actually caused a lot of effect in rising prices,
Right.
especially in Luzon area.
So this is like on top of the COVID-19, then you have the Asian
Swine flu.
swine flu.
Yes. There's another question here from May. Can one reverse the shock by using stimulus funding?
Oh, I believe so. I believe so. And this is the purpose of this data story that I made. If the government or stakeholders don't do anything, this is really the scenario. And so this is really to trigger action like stimulus funding. For example, I know coming out of the discussion with I know that BIFAR is really providing a lot of support. I think they also have like funding support for aquaculture farmers to fill up the gap of supply coming from capture fishing. So my answer is yes.
Okay. Any other questions? Suggestions? If none, thank you very much, Dr. Bersales. And we would like to acknowledge presence of former UP President Alfredo Pascual. Sir, good morning.
As President PAASE.
Okay. Okay, now
Thank
let's
you.
move on to the next speaker. May Lim is a professor at National Institute of Physics, UP Diliman. She will talk about using geospatial data to tell us more about disparities. So, May.
Unmute. All right, so good morning, everyone. It's actually a pleasure to be here. So thank you to PAASE. Yes, part of this is actually also invited myself here. Thanks to Erniel. Could you just give me a moment? My chat screen is overlapping my my slideshow. Okay, move. So anyway, let me just start. So the title of this talk is location, 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 and everyone actually likes saying that. You hear that in a lot of ads. But what I want to focus here is on actually using geospatial data itself. It's one of those things that in theory should be easy to capture, but in reality is quite not there yet in terms of what it looks like with respect to Philippine data sets. And I want to illustrate this on a very simple example in which to implement it and really tease people into thinking about where to use it further. So my collaborators in this work that I'm going to present are Louis, Damien, Teresa, and Claire. And this was actually part of the work that was sponsored by EIDR, and Giselle is actually one of the pushers of that, and of course PAEP is a great supporter of it. I actually came into this project late, so but definitely with their data sets in there, it's like a great place to start. And then my team is also funded by Picari, so we also acknowledge their support. And so one of the things that is on the mind of people right now is the notion of how are we going to reach our the sustainable development goals, and probably also it's the back of everyone's mind, how big a setback, for example, has this pandemic caused us. and has had an effect on this. And in particular, for example, the one we're focusing on in here is actually quality of education. Okay, this one, and I've highlighted reduced inequalities here because one of the things I'm going to show is what do the disparities look like with respect to how we're offering this, how it's turning out. Maybe we backtrack a bit and talk about what the Philippine scenario looks like. On the left of this figure, we're seeing the map of the Philippines in the early 70s. And as we all very well know, the population has increased since then. We've seen a lot of the urban boom. We've also seen the spread of the outward spread of these urban areas, which is for me actually a good thing. Density is good, congestion is bad. Don't confuse the two. And so the question is, how does this affect services? Okay, and so in particular, the Sustainable Development Goals, which is one of those things that's measured worldwide. And in terms of education, one of the things that you always see when saying it, how are we with number 4, quality of education? And one of the things is net enrollment rate. And this is actually given as the ratio of enrollment in elementary school to the age-specific population for a given year. And the thing is, this statistic, although it's a single value, you can see it right away and say, okay, you're increasing, decreasing, good and not good. The thing is, it does not readily show what affects school entry, distance from schools, poverty, and even perception and school readiness. And so understanding these key indicators do tell us certain things. Microscopic surveys actually do obtain granular data at the school level that do correspond to these various indicators. And the thing is, why are we prematurely, for example, aggregating them and actually just seeing averages? Or if it's not averages, you even put in the standard deviation, but then you're already essentially removing a huge part of the information that's available to you. And so the question is, what more can we know? Okay. And sorry, let me just move things around here. All right. And so in terms of accessibility of schools, there's actually a DepEd order which says that the building of schools, public elementary schools, is supposed to be one public elementary school per barangay. There are a lot of caveats with regards to this. DepEd, for example, no longer buys land; it accepts donations. And of course, there's also the issue of physical access to schools may be difficult in remote or sparsely populated areas, and therefore all those questions we want to ask: can we figure them out? Okay. And the only thing we need here, okay, is this. Well, okay, not just the only thing, but one of the really useful things that we have that we could use here is the location of schools, and this could be as simple as. And this one is obtained from DepEd with a lot of cleaning involved afterwards. But if one were to attempt to crowdsource this is as simple as making a web page. Okay. And it's just this. So important thing is you have your geospatial data, you have your latitude and longitude. And the idea is you try to overlap that with your population data, and school enrollment data. And one thing I want to emphasize is, although we're going to talk about schools here, we could also just as easily talk about hospitals or other services that have locations within them. I mean, it need not even be a service that's a public service. It could be a private service, like you have your gasoline stations, and it could be something really commercial, like how many Jollibee branches do you have, and what do they serve? And so let me go back to the location of schools. And one of the usual problems of everyone doing data work is actually cleaning the data set. So the thing here is when we realize that we've actually lost a fair amount of data once we've done the cleaning. It's about 10% for elementary schools and a smaller number for high schools. And that happened because some of the points that were there were just really wrong. You sometimes see points that's out in the sea, or some points that we actually moved, or some points that are actually duplicates. So there's a lot of cleaning involved. But in the end, we ended up with 45,725 elementary schools, and of those, 36,461 are public schools. We also did that for the high schools. One thing I should probably emphasize here is that the analysis after this is going to focus on public schools, and the main reason is there is no data on private school enrollment that's posted publicly. So we couldn't analyze it. If the data if that data set was out there, then it's possible. But at the moment, we can't. So one thing a parent may ask is, which elementary schools are close to home, and therefore can my child go there by walking, for example, or biking. And this is one of those things or taking a single jeep. You want to avoid transfers, especially if your kid is young. Or pwede bang tricycle na lang yon. So and one of the thing we're going to define here is the reach of a school. And we're actually we call this the potential. You see further later on that we define this as the potential. And it's actually just this plot. That is, it's actually a gravity-based method. It tells you that, well, if your school is within a certain radius from where someone lives, or in this particular case, not exactly where someone lives, we're going to use the centroid of the barangay, then a student would could easily go there and would accept that school. But if it's farther, then there's a lesser chance of that school being a choice. And so mathematically, that's just this. This is a truncated power law. If one think about it, it's a 1/r. It's for values less than RC, it's 1, and for above RC, it's just something that's dropping. And the thing is, this function could be any other function that's monotonically decreasing. We just happen to choose this because it's one of those physics things, like you have gravity is 1/r squared. Coulomb's law is also 1/r squared. So it's like, let's use it. But again, it need not be this. It could be exponential, or it could be any other value of alpha, by the way. And one can also select a threshold R sub c to be some other number that corresponds to what one would define as reachable. Because it could be that, in this case, we're thinking about, is it something that's easily accessible by public transportation or walking or biking? But if your thought is, driving and it's a hospital, then you could go beyond 5 kilometers and consider that. Some assumptions that we're making, that we've actually made and which are incorrect, is that when we use this model, we assume that there's elevation didn't matter. So going 1 kilometer straight up the sheer side of a cliff is really, for this model, a lateral distance of 0. So there could be a river in between, a river between 2 points, and still we're just using the distance. And so those are the two things. Roads don't matter, the bodies of water don't exist. And of course, those are not true, but for the purposes of this work, we'll just use them. And so if we look at it, then what we're going to do here is define this potential that we call phi sub I, and we've discussed this. And we talk about the effective number of elementary schools, a barangay centroid, as a sum given by the sum of these potentials around it. And the thing is, we'll also be using this potential that we're calling such as a weighting factor for distributing school enrollment. And so the key question that I just want to pose here is, to what extent does this public school system fulfill the needs of our students? And so we're going to talk about effectivity of public school access and enrollment pressure. We do know are just the following: the PSA census on the population, it's aggregated to the barangay level, and the public school enrollment as posted in DepEd. We don't know exactly where the students go, and that's one of the things we will be modeling. We don't know if they really go, and so there are a lot of assumptions, and we'll just take them all in stride. And so what we'll do is we'll assume that the school population at school I is going to be distributed among the barangays, such that the number of students S sub IB from barangay B that attend school I is given by this equation. MLAU here, MLAU, is just a term we're using for the minimum, the smallest local administrative units. Okay. And in the Philippines, that happens to be the barangay. Okay. So if we stare at it and we realize, yeah, really, that's exactly what it is. It's just weighting the distribution of the school population by that phi there, the potential that we were calling earlier. So, sorry, let me just pause a bit. My screen is not moving. Sorry. Let me just close something. All right, thank you. So the school population at I is going to be proportional to the potential phi sub IB at barangay due to school I, and weighted by the barangay population relative to the potential exerted by the school on all other barangays. So the number of students in a barangay B is just that sum of equation 2 there. And if we look at higher, increasing levels of aggregation and say, let's say at the city level, at the municipality level, then what we do is take the sum of this SIB and include all the barangays, for example, in the given city and all the barangays in a given province, depending on the aggregation level that we want. And in terms of what we're going to measure, we're going to talk about two things. As I said, effectivity, okay, of the public school system within an administrative unit K is just going to be the modeled number of students, which is what we showed earlier as S sub IB, over the school age residents at an administrative unit K. And to obtain that school age residents, again, we make another estimate. And that is, we look at the age structure provided by PSA and multiply that by, say, okay, students, the population between the ages 6 to 10, yes, 6 to 12, for example, is about 2%. I have to double check that. And then so we just multiply the barangay population by that value and get this model. If the data is actually ultimately better than that, then we could even adjust this equation further, but at the moment we don't. And so we also define the pressure, P sub K, exerted by students on the public school system as the modeled number of students in an administrative case. So you'll see that equations 3 and 4 have the same numerator, but the denominator for this one is the number of school slots in an administrative unit K. Okay, so the first one, so the effectivity is of those who are supposed to be enrolling, how many are enrolled, and or how many are enrolled. And the second one is, if this is the number that are enrolled, is your barangay or is your city serving them, or is it some other city that could probably be doing that? Okay, so those are what we're going to do. And so this is one of the key things. So if we look at that, and this is the effect. Sorry, I'm having some technical issues with my mouse here. And this is the inverse enrollment pressure. So let me just go back quickly to my equation here. Again, inverse enrollment pressure. What you're seeing at equation 4 is the enrollment pressure. We invert them because there are some administrative units with no school slots, and therefore you're going to get a denominator of 0 here and get a number that's infinity. It's an infinite pressure. And so let's revert it and show here. And the point here is that the challenge of elementary school access starts appearing as we geographically zoom in. Remember earlier we said there's a DepEd mandate to build 1 elementary school per barangay. And the challenge is still there, that it's not yet there. Okay. Just to give an idea what this is all about. So if we look at this figure, on the x-axis you have 0 to 3 in the inset. And what it means is if you have a value of 0, there's really no school in the barangay at all. And for values less than 1, there's not enough slots. And then if it's above 1, then those barangays or those regions, those municipalities or cities, depending on the aggregation, are actually serving other areas because it's above what the estimated number of students that they have. The number of students being served is higher than the estimated number of students that are living in the area. Okay. And so going back, the point here is that if we look at it, for example, as I mentioned, by aggregating it, net enrollment rate, for example, and not breaking it down geographically, then we're not going to see the disparity in access. In here, we're seeing it as we zoom in, and then the thing is the data is there, so why throw it away? And we're seeing here that there are still certain aspects that need to be addressed. So if you're saying, well, it's a barangay, pwede namang, sa ibang barangay na lang mag-enroll. But if you look at the figure after it, you actually already have the city municipality level, and that's already an LGU division. They have an era allotment, and you're saying, okay, what's happening here? There could be rules wherein a city could say, okay, we're only going to offer scholarships for our students. If you don't live here, then you're not part of it. You have to pay full tuition. Of course, that's not true in public schools. In public schools, you're allowed enrollment. You're allowed to enroll freely anywhere. But again, if it's a matter of, let's say, extra scholarship, there's allowance. It's a totally different matter. And one would see here that, okay, that might be a concern. And so again, as you aggregate, that disparity, that spread starts to disappear. But it's still there. But as you keep on zooming in, we start seeing, hey, they exist and they matter. And so going to my other questions, what happens when we start imposing administrative boundaries? So what happens to the offerings? And this is where we're going to use the effectivity, which is the modeled number of students in an administrative unit over the number of school-age residents, and see what would happen if we start saying, okay, you can't enroll if you cross boundaries. You can't enroll if you cross regions or if you cross province, or maybe not enroll, but you don't get the additional funding of scholarship, for example, which in most often something really useful. And what we see here is a distribution of those values for barangays, municipalities, excuse me, provinces, regions. And probably it's easier to see it in a map. If we start taking the differences in the effectivity of province in the Philippines for the public elementary school system with imposed regional boundaries versus those without. And what we take here is the difference and say, okay, if we start applying boundaries, who's gaining from what? So you would expect, okay, some places would be positive. It means now they have more for their students, right? Uh, and okay, so right, so model number of students in an administrative over school age residents. So if you start imposing boundaries, then you don't allow students from other administrative units to cross over, and therefore what would happen is your effectivity would uh, would go down, okay? Because this is how effective the school is, the system is. And so here we see that there's a negative value here for actually the NCR. Okay, and in fact, what you see here is the red parts are actually your really your urban areas. Okay, and same thing with the regions if you look at it that way. And so with that, I just want to emphasize here that yes, you can look at these things. Okay, but let me go back and talk about the data set itself. Okay, and walk us through that, because I mean, being a Rec 9 webinar, it's probably something of interest to many of those who are here. How do you handle the data set? So the PSGC that the PSA posts actually is a data set that codes for the region, province, municipality, and barangay. And so you have this for population, and it's periodically updated to not updated according to the census, and then the forecast within for years where the census isn't conducted. And here the other part that's really important is actually the administrative boundaries, which are shape files. And this is something that PSA doesn't collect. The organization that collects this is NAMRIA. It outlines the boundaries of the region, province, city, municipality, and barangay. And the thing is, this data set is one of the hardest to obtain. Okay, we're using a data set that's pretty old. It's from the 2000. It's from year 2000 because it was part of the PSA Datos toolkit. The problem with, so if you're probably googling running a Google search right now and say, hey, let me look for administrative boundaries in the Philippines, something would come up, and then you probably see PhilGIS. The problem with PhilGIS is that it's the metadata is somewhat, it's not clear where it really came from, how it's been updated. It's not the definitive source, in other words. And although it's useful if one would start using it for official businesses, it starts to become a concern, probably. And there are a host of other issues that one would find with administrative boundaries. For example, boundaries that actually doesn't, that might not correspond. For example, if you try to overlay it with Google Maps, it doesn't match. And those are issues that do exist. In our work, we assume that we'll take them all in stride. But again, something to remember if you're working with this kind of data set. One more thing, the part wherein we're using an old data set, that does pose some problems, because as one would have realized, there have been numerous times where barangays were split, and since 2000, and those issues, we would usually try to say, okay, let's just do the estimate, combine this, go back and use that, because we couldn't find the boundaries shapefile. And this is essentially what it looks like. So the thing here is that location, population, the information boundary, school population, and they tell part of the story of accessibility. Okay, it gives a broad view. It provides avenues for asking targeted questions afterwards. And yeah, so what I've shown here are schools. As I mentioned before, one can try to look at the hospital access. If we have time later, you can ask me about it and I can discuss it a bit. But roughly, the discussion is the same. The interpretation is something that's still something we're still thinking about as well. But running the code is straightforward. So thank you.
Okay, thank you very much, May, for that presentation. We have a question here from Ino Lansigan. Official statistics or data are often reported or presented by political units like municipalities, barangays. One issue here is that we do not have or use a common base map. This is critical in resource assessment by LGUs, operation like AYUDA or SAP, where conflicts occur. How can the use of common base map be resolved?
Yeah, that's a very good question, and still something we're trying to address. And the main solution really is for NAMRIA to step in. I mean, this is the mandate of NAMRIA to get that worked out. Uh, it's a matter of having enough probably technical people on the ground to do the updating. I mean, if before this were all analog maps that were traced, this is now something that can be updated by a GPS unit on the ground, someone actually doing walking around and tracing them. And it can be done. It's just okay, there are additional no, okay, not really problems, but I guess the question is that to what level do you want the signal to be really clean? If you're at the point where you're trying to figure out the boundaries between neighbors, it may be a bit more difficult. But for purposes of ayuda, etc., we need and the agency that's really supposed to be the authoritative agency to be the one to share the data set. Okay, it shouldn't be coming from all over the place. That's very important. Uh, and so one authority that would fix it. Gathering the data can be done. It's a matter of walking. One could say, well, one could also help with doing remote sensing stuff, and that can be done as well. You can add a remotely sensed data set to improve it. But then you still need the boundaries themselves. Kumbaga yung mga muhon dyan, importante pa rin yan. So I hope that answers the question. The answer is you need the single authoritative unit to actually step in and provide the answer.
Actually, we have a potential conflict of boundary delineation in agriculture. For example, the strategic zoning for agriculture and fisheries development zone of the AFMA law in 1998. The initial maps that they developed, which is under the supervision of Bureau of Soils and Water Management, and they don't necessarily coordinate with NAMRIA. So when they initially constructed the zoning of agriculture and fisheries, the total land area there is much larger than the total area of the country, because some local government units claims that they have this much area, which is not necessarily supported by the physical area that they actually have. So I agree that an agency that will supervise delineation of boundaries by the local government units is very crucial in trying to resolve all these issues. So there's a comment here from Dr. Bersales. Agreed to include NAMRIA to be part of the conversation. Okay. Any other questions?
Erniel, Giselle here. I raised my hand.
Yes, sorry.
So
Go ahead.
Thanks. May, congrats.
Hello.
It's a work published in PLOS 1, everyone, 2019. It's great. You're collaborating with Claire David, who's been focused on the public education systems on the elementary level ever since. And she also got this EIDR on well, access to education or impact of disasters on you know, the education of young children. So I was wondering whether the issue of disaster risk in these locations would be a significant factor. I know you mentioned that the existence of a river or you know, the topology of the you know, the location was not considered, but I think there's enough data on disaster risk of different locations in the country, starting with flooding, and that is part of the work of Eric Paringit and HAR and CP with the DOST Dream NOAA program. I don't know if that's been expanded, but I thought that maybe that's directly related to geospatial, because I think, yeah, that might have a significant impact on whether the child can walk or even use transportation, depending on the disaster risk of that location.
Right. Thanks for that. That's a very important point, and something that Claire has been explaining to us, to my team during our meetings, and that you know, they've looked at the data set, they found correlations, for example, with there are a bunch of interesting information. For example, one correlation between, you know, performance, and that's something we didn't look at in this particular work, but they had already looked at it, and you know, performance in the assessment tests. And one of the problems, for example, is if it's in a disaster area and the schools are being used as evacuation centers, then that cuts into the school time of the students. On the other hand, you would also see the effect of students actually being used to some disruptions. So, for example, in the Pico region, where you get frequently hit by, they're the first ones that you're usually hit by typhoons. They tend to have adjusted to that situation, as opposed to, you know, places which experience a one-off really disastrous flooding event. Then the adjustment of the students to that situation is harder. And so these are something that has been looked at by other groups, and indeed they do have effects on the performance of the students. I guess one of the things that we haven't really looked at the moment, and you know, something that your question has triggered, is, for example, the effect of having, you know, remote learning right now. And the remote learning part is not about being able to access physically the schools. It's about being able to physically access the web or getting online. And that's also geospatial data. If you look at what's the signal, what's the available internet facility, because, you know, if you have a fiber running through the area, you can run Zoom meetings. If you have, you know, 3G or worse edge, you cannot even join Zoom. You probably cannot even connect or do a Google search anymore. So it depends. That's indeed geospatial data as well. It's in a different layer of access that we're talking about. And so those are the students who would, you know, get their modules physically. But we do know that when they get the physical modules, they don't have access to the teacher actually teaching it. So there is another layer of disparity that's going to happen there.
Thank you so much for a very insightful response to my question. So it's a very complicated situation. So that expands your space into the 3D space, including atmosphere. So the connectivity. All right, thank you.
Okay, we actually have a pahabol question for Dr. Bersalis, but let's finish first One more question for May from President Pascual. The new normal is digital, and in the digital world, geographic location is no longer a determinant of access. The key is connectivity. Are you developing models to take into account the impact of digital disruptions? May?
We're not doing that at the moment, but I think it can be done. That's a very thank you very much for that. That's a very it's closely related to what I mentioned earlier. It's really crucial. So what I talked about earlier was having the connection to begin with, but again, the other part is if you have the connection, but you're in a region that oh yeah, a typhoon hits you today, tomorrow, today also you don't have power, and it will take 2 weeks to restore power in your area. Okay, you don't have internet as well. You've lost your connectivity. Uh, you're dependent uh, uh, on a single provider that's wireless, and it there's if there's a thunderstorm, your signal goes down. What would happen? And so yes, indeed, it's crucial. It's very important that the different kinds of connectivity and how resilient they are do happen would definitely have an effect. It would talk up with the determine access to your teachers. It would determine access to your peers. Can you even talk with them? I mean, that's one of the things we've lost with remote learning, being able to talk to your classmates and have the confidence that you're all not getting the lesson, or you're sharing ideas on how to solve the assignment. And those are important details that have to be addressed when we talk about online learning. So
Actually,
thank you for that.
yeah. Actually, sir, I have a data science student who is supposed to work on for his capstone on something related to this. Unfortunately, the data he was requesting from a telco was not granted because of the secret. So we're supposed to develop the definition of digital neighborhood system and so on, and then look at the spatial distances in terms of the digital neighborhood system. Uh, but still, I'm quite hopeful that the telco will be able to grant his request for data access. Um, okay. And I think this is a comment from Dr. Bersales. Topology with weather indicators could also be a determinant of incidence of diseases like dengue, uh, related to the work of May. And uh, question for Dr. Bersales. Do you think an earlier enforcement of quarantine will have a greater effect on the decline of the economy? How do you describe this projection statistically, whether greater or lesser? How about the different levels of quarantine? Do you have data on this factor? Can you stratify your data according to urban versus rural areas, or compare the different cities? This is for me, Erniel. Maybe she answered this, but I had to take clinical, so I missed some parts. I think not yet. So
Yeah, thank
any
thank you.
response, please?
Thank you very much for the question. Now, the data on economy are available for regional. We don't have the PSA is still starting with provincial product accounts, so we don't have provincial nor municipal level estimates of economy the way PSA estimates quarterly national accounts. As regards impact of the different levels of quarantine, that's an interesting study. I didn't include it in my study, but these can be done where we will study economy of the various areas in the country regions specifically, and how their economy performed under these different lockdown scenarios. And some projection could be done by doing some scenario building given a model that could be developed. In fact, in my mind, that is a very important model that needs to be developed, given that the government has to create this balancing act of, health and wellness versus economy. In a way, that question comes across to me as a suggestion on what else to do. Thank you.
Okay, thank you very much.
Oh, excuse me, Ernst.
Yes,
and we don't
sure.
have yet urban rural. So we just have the provincial level measures of economic performance. Regional level performance of economy. Thank you.
Okay. Yes, Dr. Pernia. You're muted, sir.
Yeah, I want to ask how efficient and accurate our geospatial technology is in the Philippines. How advanced, how accurate, how efficient has it become already?
So maybe Dr. Bersales or May want to respond.
Maybe I can answer part of that. If we compare, for example, where we are versus where Africa is at the moment, I would say they're miles ahead. As in, they're way beyond where we are in terms of working with geospatial data with respect to doing agricultural census, for example. We're really behind on that.
Africa is ahead, huh? That's rather
way ahead.
Yeah,
way ahead.
That's not good to hear.
Yeah. If you look at papers that are published on agriculture and GIS and spatial data, you'd see a lot of it coming from Africa. Not much on our side, unfortunately. In terms of technology itself, it's really not a problem of being able to get the technology. It's there, it's commercial. It's really agencies in charge of the various data collection not being, having the geospatial data is not part of their priority in terms of, making sure their data sets also have that. And so it's more of a fundamental issue that's existing. For me, that's the problem. It's not part of the DNA, if you want to think of it, of the agencies. Our government agencies don't naturally think that geospatial data is important. In fact, it's not as well shared. If you want to get data from NAMRIA, it's possible, but there are a lot of contracts that you have to fulfill. The private sector would probably have to buy the data set. It's not as simple as one would hope it would be.
Dr. Bersales?
Yeah, thank you. Thank you very much. Yes, well, specifically PSA, I can talk about PSA. PSA hasn't yet used geospatial information in the conduct of agriculture census. Doing the agriculture census is still really a challenge for us. But for the conduct of the census of population and housing and the census of population, the PSA has been using geospatial information and has its own base maps. The problem really is the purpose of these base maps of PSA, which are really updated, are for internal purpose only. They cannot be shared really officially, because the official agency that is supposed to provide such is NAMRIA. Okay. That is why I also, maybe a next PAASE webinar could be a discussion with May and others doing geospatial studies with NAMRIA. And NAMRIA is under the OST, so maybe Sir Dr. Pernia, being one of our heads someone who everyone looks up to could be part of the conversation, something to influence. But May is correct. We don't have studies much on government using geospatial information because that has not been a practice of government. But the geospatial information is actually already being used by various government agencies, specifically PSA. If you look at the PSA website, all of their data visualizations have geospatial, well, the simple ones, but they've started doing dynamic mapping with ArcGIS there. Thank you very much.
Now, our comparator countries are really those in ASEAN. That is where those are the countries with which we tend to compare ourselves with. I suppose they're also more advanced than we are in terms of geospatial technology.
Yes, sir, especially Indonesia.
Yeah. Okay. So we have to do something then about this.
Sir, the key is Namria.
Okay.
Okay. Now, actually, May and I co-chair Rec 9, Mathematical, Statistical, and Data Science Research Cluster of PAASE. And that gave us, May, right, an idea of what will be our next webinar. Maybe we can talk more about geospatial research in the country. I can also share some of my work with the private sector specifically, and some of our papers that are currently under review. So we will maybe we can commit to our PAASE president that soon we will organize that webinar on geospatial analysis in the Philippines.
Ernst,
Yes.
Dr. Barrios, one important note. We don't have a standard of addresses in the Philippines. There's another headache.
Yes.
No standard on our address. So if you go to the rural areas, you don't have a specific address. It just says Purok something. And then you have to go to the barangay captain to look for the resident. So that's another discussion that would be interesting as part of the geospatial discussion. Thank you.
Ayan. So maybe May and I will talk about it a little bit more, and then set a webinar soon.
Danielle.
Yes, ma'am.
Yes, I just want to make a plug. Okay, so Lisa will give a Friday webinar on July 16, and she's gonna talk about women data stories. So all the data on women, adult and children. That's on July 16. So that's a very important webinar.
Yeah.
And I invite everyone to join that. Okay.
Okay. Yeah. Thank you very much. We still have one more speaker. Sorry, Iris, we didn't forget you. So the third speaker is Iris Gauran. She's an associate professor at the School of Statistics, UP Diliman, and she will talk a little bit different topic, but it's also on empirical-based decision making. She will be talking about Bayesian variable selection using knockoffs with its application to drug resistance. Iris, you're muted. You're still muted, Iris.
Okay na po.
Okay.
Opo. Good morning po to everyone and good evening to some. So I have a very different story to tell compared to the first two speakers. Pero if you could give me a couple of minutes to just share with you this different perspective, then I would totally appreciate it po. First, I would like to thank Sir Urniel for the invitation and of course PAASE for the opportunity to be able to present this work. This work is one of my passion projects po. So this started in 2019 and productively I was able to finish a portion of this work with the help of my student Jurelia. But the overall story that I wanted to share is this is looking forward, or at least if in the first two talks we were looking at how to analyze the data that we currently have, this one is more towards looking forward. One of the lessons I have learned from Sir Erniel early on when I was beginning my research as a very as his apprentice many years ago is that you should be able to produce methods that will be relevant 4, 5, 10 years from now, and you should be able to preempt the need for those methods before the data for those cases even exist. Otherwise, the way we would analyze data is always reactive. There's this data and we need to analyze it. And the tendency is that we develop the method right then and there if the method does not exist yet, or we rely on classical methods to develop, to answer the problem at hand. So this is as an overview, I will give you, of course, an introduction of the problem that we're trying to solve, some key concepts, a little snapshot of our proposed methodology, and some results. So for the introduction, the main application of this data set is in drug resistance. So we are all familiar about how fast the vaccine for COVID was developed. And in fact, one of the reasons for vaccine hesitancy currently is because of the speed at which the COVID vaccine was developed. And some people at least are skeptic na talaga bang kayang ma-produce yung vaccine that fast? Because HIV-1 is one of those cases that we have right now, autoimmune problem that we have, which does not have a vaccine yet. So on the left figure here, what you can see on the x-axis are the respondents. So there's at least 700 of them. And on the y-axis are positions of single nucleotide polymorphisms or SNPs. And the black dots are actually the SNPs. We can think of them as genetic aberrations or mutations, but that's like way too simplistic. But in some sense, we are looking at the genomic information for a person. And on the right-hand figure, what we see is the snapshot for this same set of respondents of the log-fold increase in drug resistance to nevirapine, which is one of the antiretroviral drugs for HIV-1. So the problem that we currently have with viruses, or in general with the diseases that are existing for mankind, is that we develop a drug for that disease, and before long, a drug resistant strain comes along, and then the current developed medicine or drug is no longer effective in protecting us from that specific disease. So yun po yung konteksto, or yun po yung kwento. Kaya po this particular study, as I mentioned, is a passion project because in 2019, when we started this, there's still no COVID-19 yet. But around that time, we are heavily concerned already with the exponential, or quote unquote, exponential increase in the number of HIV-1 cases in the Philippines. And one of the reasons why we were looking at this study is because NIH was able to secure some funding to be able to develop kits which are cheap, accessible, and they would be able to help us diagnose HIV drug resistance. And by then po, the targeted release was for 2023 or 2023. But the thing is, with the entire pandemic happening and disrupting the whole timeline of multiple projects, including the OST projects, then this is probably one of those which is affected. But around the time that we're developing this, the perspective is very simple. What would be the cost of misclassification? So of course, if it's supposed to be simple, as with so many kits that are existing currently, then for a layman, we don't really need to understand which protein is being tested, what particular strain, or whatever details there are genomically. But for a layman, at least, or for somebody who doesn't know much of the molecular biology involved, then we simply have two results. Either it's positive or negative. And since it's indicator of the presence of any disease, we almost always do not like the positive result. So the idea is that what if we have false positives? And another idea is, what if there is somebody who already have the disease but wasn't detected by the kit? So false positives in general in drug resistance causes multiple problems, particularly if you were told that you have HIV-1, then the natural tendency for you is to take drugs, antiretroviral drugs at that. But if you don't really have it, then it may lead to unwanted physical side effects, of course, needless financial costs, and the risk of treatment failure, leading to HIV-1 developing into full-blown AIDS if you were in fact positive, but the kit was not able to detect that you are positive, then you wouldn't be treated right away. So there are costs for misclassification, and we're talking about human lives. So as I mentioned, the whole perspective is a little um, more towards, I'm not sure if I'm overly excited or passionate about this, or it's a little on the scary end because we're trying to venture into unfamiliar waters, particularly because since the kit is not even produced yet, so we don't really have data at hand. So the question is, how do you perform an analysis if you don't have data at hand, but you expect this problem to be very relevant so many years in the future? So doon po pumapasok yung buong perspektibo ng kwento na parang paano ka magkukwento kung wala kang ikikwento? So, so paano ka magkukwento kung parang ang basis mo ay puro ideya lang at walang actual facts to support these ideas? So we look at this as a statistical problem. So this is where I shift gears and look at it a little more towards the theory end. So this is statistically a controlled variable selection problem wherein suppose we observe a response Y and we have little n observations, how many patients we're looking at. And for each of these patients, we collect several information about them. For simplicity, let's just call that x's, x1 up to xp. And then we would like to discover which of these p SNPs is important in detecting drug resistance, while of course making sure that we correct for the cost of misclassification, or that is, we keep the ratio of incorrectly selected genes and the selections controlled under a specific threshold. So the whole idea po here is that we don't want to be overly aggressive in saying, discovery, discovery, discovery. But we also did not want to be overly conservative in saying na, wala po talaga dito kasi we're scared of making a mistake. So it's supposed to be a balance between being brave enough in saying that a discovery is a discovery, and at the same time, of course, kasi with bravery comes the question of false bravery ba yun? Or false discovery ba yun? So in this case, we just wanted to maintain a balance between these two. So importantly, we wanted to select important explanatory variables while minimizing mistakes. So the whole problem po is very interesting because from something which is totally more towards the biological application, we can translate it to the language of statistics. And in that sense, since we're able to translate and shift gears, then of course, we have key methods to deal with this problem. As I mentioned earlier, this problem of selecting important signals or important explanatory variables is very old. This is like age as old as time problem in statistics. But we deal with this via the so-called regression. And more recently, we don't just do classical regression, we actually penalize the regression process because we wanted to correct for biases and the variance, and we wanted to control between those two variables. But simply put, why are we developing new methods if old methods already exist or classical methods already exist? So the reason for that is because This lacks theoretical guarantees of FDR or false discovery control. It's telling us that there is a probability of us producing false discoveries, and the probability of false discoveries that we have, or the amount of mistake that we will eventually commit, is not controlled. Meaning, if I set a threshold that I'm only allowed to make like 5% mistakes, then I exceed the initial threshold that I specified. And then there are also recent, this is not very recent, this is a 20-year-old technique, which is the Benjamin-Hackberg correction. But as with statistics, if you have assumptions, those assumptions can easily be violated by the real data at hand. And that's one of the problems of Benjamin-Hackberg. It's very beautiful in terms of the theory, but in terms of the applications, independence is one of its assumptions. And we almost always have dependent data sets in practice. So that's why this also will cause problems. Now, more recently, in fact, 2015, very, very fresh, they were able to come up with a technique called knockoffs. So this is an all-in-one technique for false discovery control. But since this is the first iteration of a new technique, then it also has flaws. All to convince you that there is a need to develop techniques for this particular problem. So before I proceed with how our technique works and what our technique is all about, let me piggyback on the last particular topic, which is about knockoffs. So we're all familiar of knockoffs. In fact, pumunta lang po tayo sa Divisoria. 100% sure, first few steps pa lang po natin, we'll definitely see a lot of products which are knockoffs. So the whole idea of knockoffs is both brilliant and simple because we're using fake covariates. So they are cheap because that's what knockoffs are. They're supposed to be cheap. They're supposed to be easy to construct. And they should be, one of the most important characteristics of knockoffs is that they should be constructed like the real thing. But we know that they are fake. So, of course, the level of it being close to the real one varies. We know cases such as DVDs, which are, at least in my perspective, masyado pong malayo. Itong dalawang to, language pa lang, magkaiba na. Pero there are particular knockoffs that would deceive the and the not expert eye. And for branded products, that's typical. So why use knockoffs in statistics, and how do you incorporate knockoffs in statistics? So knockoffs solve the control variable selection by providing us with a negative control group for predictors. And it's supposed to behave like the original design matrix. But in terms of its relationship with the response, it's supposed to tell a different story. So what we have here in terms of the values are the different lines. So as you can see, we have the blue lines. Whenever our covariate or our X, the information or feature we have extracted from the patient is in fact significant in explaining a response Y, say any information about the drug resistance. And we have the red ones when it is not supposed to be sorry, we have here X is blue versus X is red when we have X is really a signal, whereas we have X here is blue versus X is red when they are really not true. So what we mean by this is that if X is true null, and when we say true null, it cannot significantly explain our response, then we don't observe a line with a steep slope. So when X is not a signal and it's quote unquote noise, then it's not supposed to characterize or explain any information about a response. So this is the original layout that we have for the classical regression, whereas this is how it will behave for the knockoff. So as you can see, for the first row, the behavior of the blue and the red lines are more or less the same. Whereas when it is in fact a signal, that is when it should be able to explain some variability about the response, then we see a steeper slope versus a knockoff, which is still not able to explain the response. So the idea is that we build this design matrix X for the knockoff. So we have our data. So we can just think of it as we have our data, we copy the data, and we copy the data in some sense such that we both augmented data information will be used to describe the response. What the original data can tell us is information on signal or noise, whereas what the knockoff will just tell us is supposed to be purely noise. So if we have the case wherein the difference between the knockoff, the signal, and the knockoff is very high, then that tells us that kapag nakakita po kayo ng dalawang Louis Vuitton bags, tapos po isa doon original, isa po doon knockoffs, at na-detect nyo po talaga na magkaiba sila kasi magkaiba yung spelling, then alam po natin na meron kayong sufficient evidence to conclude na one is real, one is fake. Whereas kapag hindi nyo po fully ma-detect yung dalawang yun, kasi in comparison, halos pareho lang yung real at saka yung knockoff, then we don't have enough evidence to conclude significance. So yun po yung idea ng procedure. So we wanted to look at this because this is new. This is very, very young. And in fact, as a trivia, Rina Fogel-Barber, who is the first author of this particular topic, just won the COPS President Award last 2020. And she's a very young budding statistician. And for her to win such a huge award is very promising in terms of the kind of work that she does. And by ensuring that our false discovery rate is not too high, then our discoveries are reliably true and replicable. More importantly, replicable. So for example, if the nominal FDR target is set at 10%, then we know that at least 90% of our discoveries are true under the false discovery rate control. So why are we proposing a new method? And coupled with the whole idea of why don't you just use knockoffs? The idea of knockoffs is that you don't have data. So whatever data you have, you include more data by copying whatever information you have from the original matrix and then using everything to be able to detect significance. But here, why are we using the paradigm of Bayesian? So the dilemma is that we statisticians kind of get lost into the rabbit hole, or not we statisticians, I can just speak for myself. I can easily get lost into the rabbit hole of making things more complicated. And because I'm overcome by my excitement on working new things, I might end up making things more difficult than it should be. But the dilemma is not that. So here, I was able to be entirely self-aware that it's not about making things more complicated. There is really an underlying problem in statistics, and particularly as it relates to the entire scientific community and how we interpret the results that are provided to us by whatever study. Then the dilemma is we misinterpret the p-value. And we misinterpret it. I have still students at this point who think that the p-value is the probability that the null hypothesis is wrong, or that it's the probability of a type 1 error, and so many other misconceptions, and that everyone will jump with joy if their p-value is less than 0.05. So one of the problems in the entire statistical community really is how to come up with techniques that can bypass the problems brought by p-values. And it is a very long problem, so I wouldn't go there. But one of the perceived solutions, at least as of 2017, one of the perceived solutions is to go Bayesian. And the reason for doing this is because it allows us comparability among the SNPs within and across studies. If we perform multiple genome-wide association studies, then we should be able to compare the results. And another thing is that it can tell us an effective measure of importance, as well as if we do have prior information, then we can utilize prior information. But fret not, if we don't have prior information, then our results will more likely converge to the frequentist result. So in the whole diagram of testing, we we should be able to create what we call test statistics in the whole hypothesis testing story. Test statistics provide us with evidence on how we deal with the null hypothesis. And we don't just rely with the test statistics. We also rely on the threshold. So if our test statistic exceeds a certain threshold, then we decide this. If it doesn't, then we decide this. So bottom line, we need test statistics and thresholds to be able to come up with a decision. And what we're doing here is we're augmenting the second step, which is creating test statistics. And we will use whatever threshold the original knockoff procedure produces. So all that to say that this is supposed to be a Bayesian method, and we wanted to create something which is easy to implement and understand. I hope I was able to convince you that there is merit to using knockoffs, but I know since I jumped all the theoretical properties and all of the sufficiency and optimal property results that they produce, then it's probably not as convincing. But nonetheless, the whole idea is meant to be simple. It's meant to be useful for somebody who doesn't have the data currently and is using to augment the copies to be able to come up with a decision. And literally there is scarcity in everywhere we go in terms of reading this. And even the original knockoff procedure, they're still building a team currently. They have a team in Stanford developing techniques regarding knockoffs, because this gained popularity when Rina won last year. And so many statisticians wanted to jump ship and just join whatever this popular new topic is. But initially, even before the uproar in the topic, the interest that it the reason why it caught my interest is because um it's a very simple idea. If you don't have data, then you copy whatever information you have, but you don't literally copy it. You copy it intelligibly, and you copy it in such a smart way that facilitates your decision making. So that's, for me, the simplest sense to describe the process. So in terms of the methodology, I wouldn't dwell much on how we proceeded with this. This is highly computational in nature. The reason for this is we needed to develop simulations for this. As I mentioned, po, there is currently no data available for the Philippines. I would really want to get my hands on the COVID-19 data set on drug resistance, but particularly with the existing resistant strains or new strains. But since that's not currently available for me or for anybody as part of the public, the general public, then I would have to resort to my simulations, and some part of it would be the existing data set that is available in the US. So first, we specify in our simulations what the proportion of signals are. So how many signals are there? So if we say 10%, so we should be able to detect 10% signals, and the remaining 90% will be noise. And then again, we augment the two matrices. We constructed the knockoff matrix by the ASDP method, which is one of the techniques used for knockoff construction. And then using both information, we generate actually the vector of observed responses. The vector of observed responses just depends on the original one. It just depends on the original. Particularly from step 1, we can jump to step 3 right away. Step 2 is just necessary for the analysis itself. Now, this is in conjunction with the problem I mentioned earlier about p-value. So instead of computing the p-value, we compute the posterior probability of us observing that the null is true. That is, our coefficient for the jth covariate is indeed 0, given whatever data that we have. And this formulation directly follows from Bayes' theorem. So nothing entirely fancy about this, but this is in fact the probability that the null is true given that we have observed this data, which is our response variable, our covariates, and the knockoffs we have created from our original set of covariates. And the thing is, and the important thing that I wanted to point to everyone, which is the message of this method, is that this method is in fact a rabbit hole. There's so many things we can do about this, because the question now is, how do you estimate pi null? How do you estimate pi 1? How do you estimate the density for the null distribution? And how do you estimate the density for the non-null distribution? So there are so many techniques being developed currently in order to deal with this posterior probability, just to get away with the whole notion of p-value. But since we're trying to avoid one problem, we come across one more problem in the process of avoiding that other problem, and that problem is estimation. But fear not, since we statisticians love estimating, then that's one of the things that we're supposed to be good at. So in this case, the method that we dealt with proposes the use of Bayesian lasso and Bayesian linear regression. Another thing that I wanted to point out is that in this estimation, there are two things that we can do. Either we assume something or we let the data speak. So if we assume something, that would be called the theoretical distribution, because we're assuming something. But if we don't assume something, then that's called the empirical distribution. So all to say that our proposed methods are comparing both the theoretical version and the data-driven version. And this is just a snapshot of the algorithm. I wouldn't go through the entire updating of the Bayesian lasso, but the whole process, it's just using the whole context of posterior distributions. And the big word in Bayesian is updating. So what we currently have is the data. So the data comes in to play. And then if we add some prior information with that, then using these two information, we can arrive with what we call the posterior. And then the whole computational process is this algorithm. So there are multiple parameters at play, which we should get draws from, and we should update. So that's why the keyword really in Bayesian is updating. You update whatever information you currently have from the data or from the likelihood using the prior information. So our proposed test statistics are 5 actually. We have multiple methods that we're playing at and multiple ways to come up with a decision. But in simplest sense, this is what we're doing. So let's look at it as T1, T2, and then T3. So of course, there's A and B, comparing two different thresholds for comparison. If I may highlight, the thresholds were from the original procedure. But our proposed procedure is really how to come up with the decision via the test statistic. So here, with the deltas, so somewhere around step 8, we will have to compute some delta, and we would have to compute some false discovery, a local false discovery rate. So which is actually presented here. So we will have to compute that somewhere around step 8. So the idea is that here in T1, these are absolute. It's either we reject or we don't reject. Whereas in T2 and T3, whenever we use L instead of delta, what we're coming up with is probabilities. So this is the probability that we reject, and this is the probability that we don't reject. So whereas in the first one, it's absolute, you reject or you don't reject. The second and the third one deals with some soft measure, which is some number from 0 to 1. Because the first method is absolute, it's like 0 or 1 endpoints. Whereas everything in between T2 and T3 is comparing the probabilities. And for the second one, it's just comparing the probability of the original data. Whereas for the third one, it's comparing the probability not just of the original data, but for the data that we have originally versus the knockoffs. So just to give you a perspective in terms of the simulation studies, we tried at least 4,000 scenarios, playing with the number of observations, parameters, how much the signal is, and what our test statistics are. And of course, we have to check for the priors. What if our priors are significantly impacting the inferences that we can have? So in terms of the real data set, what we have is the HIV-1 resistance database with 745 observations, 313 are SNPs, and we limit our analysis to 3 drugs, but I will just talk about one drug, which is nevirapine. Um, so in terms of the results, first, let me show you the snapshot of the simulation results. So what I'm comparing here is via Bayesian lasso, Bayesian linear regression, or what if I assumed an empirical distribution. So for both Bayesian lasso and Bayesian linear regression, there's a set of theoretical assumptions that were done. So the whole idea here is to just look at the last part. So the idea is that if this number is positive, so in terms of the power, so that's telling us that the proposed procedure versus the frequentist version of the proposed procedure, if that's the difference between the proposed procedure's power and the power of the best frequentist procedure. And this 0.978 is telling us that the proposed procedure that we have has power equal to 100%, but the competitor only has 2% power. So that's why the difference is very high. In other words, if this is a positive number, then our method is better. Whereas the false discovery rate is the false discovery rate of our method versus the frequentist method. And in that case, if this is negative, then that's telling us that our method has lesser false discoveries compared to the existing frequentist methods. So in other words, our metric for success is that this quantity should be positive and this quantity should be negative. And if we look at the results, that's what we see. We see positive results for the power and the negative results for the FDR. There are cases wherein the false discovery rate are comparable by say 0.004, that the frequentist is slightly better. But overall, our methods are in fact better generally in terms of the scenario, particularly the high dimensional case. Now, in the interest of time, let me just show you the results of the sensitivity analysis. So if we try multiple specifications of the priors, if we move the prior and the shape changes, then these are the false discovery rates. And as you can see, it is not sensitive. In fact, the method is robust into changing these values of the priors. And another thing that was asked was in terms of the correlation. So what if the variables that we're looking at are highly correlated? Then truly, it would affect the false discovery rate, but the false discovery rate of the frequentist method and not our method. And finally, the results for the real data set, which is not the Philippine data set that I badly wanted to look at. So it's compared with the TSM panels by Ree et al. In 2005. And the results are similar to our simulation studies. So what you can see here are the blue ones are the blue discovered already biologically. So, and the red ones are not in the panel, meaning they are worth looking at, that we might be interested in studying them. So overall, in terms of comparison of techniques, what these plots are telling us is that we were able to detect whatever is detected biologically already, plus some more. So it merits looking at this particular SNPs. So as a highlight, we were able to detect one position. So whatever technique we look at, whether it's the frequentist one or the proposed one, we were able to see one particular position in terms of studying drug resistance that could be important in terms of the discovery of SNPs related to drug resistance. So this is not in the other techniques, but our method were able to detect this one. Biologically, I'd be very curious how this translates to the wet lab, because what we have is clearly the dry lab analysis of this. And conclusions. So we were trying to demonstrate the competitiveness of the proposed methods through simulation studies, and we wanted to say that these results are robust to different choices of priors. The set of results that we have is way longer than this. The number of months we spent doing the simulations is too many. But in the interest of just providing you a perspective of this study, then we wanted to say that there's potential in using these methods in finding new discoveries in genomic data set involving HIV-1, particularly in drug resistance. And as I keep mentioning throughout the entire presentation, I would be very, very curious and excited to look at other genomic data sets, particularly as they are applied to COVID-19. No one was able to see the pandemic happening, or uh, there is a TED talk by Bill Gates, but nonetheless, most of us have did not realize that this pandemic will happen in our lifetime. So we are very reactive in terms of the methods that we use in terms of dealing with the data sets that we currently have. And it would be very, very fruitful for the entire community to be sometimes proactive when we deal with these problems. That's all po, and thank you very much po.
Thank you very much, Iris, for such an extensive presentation, discussion of the new method that you are proposing. We have a few questions here in the chat box. First, can we apply your learnings on the current COVID-19 treatments and diagnostics with ample data? Start with local NIH diagnostic kit and local treatment study using VCO, for example.
Ideally po, yes. The only dilemma that we have in the current structure that we have in analyzing things like this is by the very nature of the study po, it's highly collaborative. So even if I was trained to pre-process data, I honestly have no skills in pre-processing data, genomic data that deals with this. So I would have to rely on colleagues from whatever department or on the scientific end to help with the cleaning. But once the data is sufficiently clean, or at least we can rely on the accuracy of the data that we have, then yes, the answer po is yes.
And I think this is related to that. From our President Giselle Concepcion, Iris' admirable endeavor for data on HIV and other viral infections as basis for modeling resistance, I suggest you connect with Dr. Alan Tenorio. Uh, Came home for a while, now back in the US. So the Google link is given here. Also, perhaps look at the data on HIV in Thailand, which is more extensive, good to model future based on available good quality data set. Also, SNPs in one level of analysis, but some genetic or base mutations are silent because of codon redundancy. And another important level of correlation and analysis is amino acid mutations. That's it. I think this is more of a
Yeah,
yes,
no, here's
ma'am.
sorry, I'm about to leave. So Iris, I think is this is our next gen leader in stat and data science. So congrats, Iris. And one of the most complex to model would be drug resistance. And well, Alan Tenorio is a data engineer in this field. He's an MD. And unfortunately, I don't think he found the climate in the Philippines challenging or supportive enough for him to pursue studies. He's back in the US, but he is perfectly open to collaborations, and used to work with Edsel Salvania, our PAASE member. So Edsel Salvania is with NIH of the UP Manila, and a faculty member of College of Medicine and PGH. So I think it would be good to connect with them. And I just wanted to emphasize that SNPs are easier to obtain. Data on them is easier to obtain rather than amino acid mutations. But actually, it's those amino acids that are the functional units, biomolecular units of drug resistance. Amino acids are interacting with the drug, or say with the antibodies that are generated by the vaccine. So Yasmin Ronquillo, MD, and mall biologist is in the audience, and she might want to expound on this better, just so you're able to access good quality data for your stat methods and strategies. So thank you very much, Iris, for considering my suggestions.
Thank you po. I agree po dun sa perspective na starting point lang po talaga ang SNP kasi we really have no starting point in terms of the data at hand, and it's difficult to just rely entirely on simulated or manufactured data. And I wanted to look at the metagenomic end of this as well as yung impact po ng environment in epigenomic sense. So there are more things that play that are not incorporated into the model. And of course, we know that. That's part of the assumptions that we weren't able to address. Pero po, we, in the presence of data, we would gladly look into it. Thank you po.
Thank you. There is a message here for me on variants of SARS-CoV. Ma'am, would you like to mention this verbally?
Yes.
Yes, ma'am. Okay,
Yeah.
Dr. Ronquillo.
Yes, I'm Yasmin. Give me 1 minute here. There we are. Sorry, it's summer here. The heat is awful. It's 100+ degrees in Salt Lake City. It's climate change, they say. So my question, well, not really a question, but my comment is, the variants of the SARS-CoV-19 are identified by the spike protein variations. Now, one amino acid is changed for the different variants. Does your work also, or can your work be applied to drug resistance due to protein changes like this, and not at the genomic level?
I would be curious to look at that po. So definitely in the way we address questions like that po is we'll have to simulate the data first and then look at the false discoveries in the simulated data set and then translate that to the real data set. As it is, the technique itself, if applied to protein data or at that level po for COVID, I think it's like very, very naive to implement it right away. But with the proper modifications, assumptions that we need to implement into the models, then I think po, it definitely can be improved to address that. Particularly po, the beauty of the Bayesian technique is that we can expand on the model assumptions depending on the prior information that we have. And one of the prior information that is available to us is via subject matter or domain knowledge actually. So the knowledge of particular fields, lalo na po kung may historically available information on certain positions or kung ano man po ang tawag doon sa inaaral, then clearly po the existing study can be improved to address that po. I wanted to be optimistic enough to say that.
Yeah, it's very interesting. I am interested in it.
Opo. It's very, very new po. And in the US, it's just gaining traction in Stanford and Princeton, at least in the study groups in biostatistics po. But in the Philippines, medyo kahit gustuhin man po ng mga faculty from School of Statistics to develop teams about this, we really don't have data sets to implement them on. So it's a very difficult struggle for us. But even if we do, mag-a-adjust din po kasi yung layout ng problem doon sa cultural context. Kasi di ba po, may environment at play din po. The data set I used for this study is US data set. So clearly, it won't be the same kung yung diagnostic kits po ay developed in the Philippines and used in the Philippines. Yun po.
Thank you. Thank you.
Thank you po.
Okay. Any other questions, comments, suggestions? Yes.
Yeah.
Can I backtrack? Can I backpedal? Yeah. Can I backpedal to the presentation of Dr. Lisa Bersales?
Yes, sir.
A dear colleague of mine once upon a time. Anyway, I wanted to catch up on her presentation on co-integration of the informal sector. So I suppose there are several sectors in the informal sector, but the co-integration can it also be done with co-integrating the informal sectors with the formal sectors? And I'm also interested in finding out what because production output of informal sector is not recorded in our PSA accounts, national income accounts. So I was wondering, what is the estimate of the output or the production of the informal sector that we don't know about because it's not part of GDP as it is reported. Thank you. I'm sure this is nothing. This is just very ordinary to Dr. Lisa Bersales.
Sir, I'm always happy to see you. Anyway, yes, sir. I'm writing down all of these questions because for me, they are actually suggestions on moving forward. I did not include the formal economy in my study of co-integration with the informal. I will do that because what I did was just doing some descriptive analysis of the history. As regards recording of the informal sector in the estimation of the national accounts that is done quarterly, actually, sir, meron po ang PSA, except na hindi kasama sa report. Parang nagiging internal document lang. And yes, sir. And this is because the estimation of the informal sector is indirect. PSA is just starting now to include in the data collection questions on informal economy, starting with the labor force survey. So they are now asking through household survey, involvement of households in informal economy. So that there will be two sources now, the establishment survey and then the household survey. So nandyan siya, sir, except not reported.
What is the order of magnitude?
Sir, I don't have the order of magnitude now, but now during pandemic, 35% of total economy is from informal sector.
Well, that's quite big. Yeah. Yes,
sir. 65% during the pandemic. Before, it was already down to 32%, 30 to 32%. And then the pattern is it's the agriculture sector that grew in informal economy. Services and industry almost the same level eh. Ang worrying na dumami yung informal sector sa agriculture.
Yeah, I'd be interested. Maybe I can do some research later about comparing informal sectors in the Asian countries. What are they? I mean, to what extent do they matter in terms of the total economy? Yeah. Anyway, thank you for that response.
Yes, sir. Let's connect for whatever data you need. Thank you.
Maybe we can collaborate on that.
Oh, we should, sir.
Okay.
Thank you.
Okay. Thank you. Thank you.
Okay. Okay. So we are now open for questions to any of our three speakers, starting with Dr. Concepcion. I think you have questions.
Sorry, this is the very last because I'm about to leave. I just wanted to tell Iris that this webinar is so important to you because it opens doors to collaborations within and outside PAASE. And here we have Yasmin, our MD mole biologist, actually an ophthalmologist, who's expressing interest in your research. Now in PAASE, we have other stalwarts who are doing SNPs research. In particular, I'll point out Pedro Jose of George Washington University. He is a world expert on hypertension, essential hypertension. And that's not infectious, it's lifestyle metabolic syndrome related to diabetes and heart disease, but he has extensive data on SNPs. And his lament is that only the Philippines data on SNPs in relation to clinical hypertension has not been well documented because he's already identified several SNPs. So I would like to suggest that you explore these kinds of collaborations with our world experts found in PAASE. So that's it. That's my final comment. Thanks, everyone.
Thank you, ma'am.
Webinar serves its purpose. No?
Opo.
We're interdisciplinary here and we find new ways of working together.
Opo. Thank you very much po sa collaborations na magpo-form. Sana po maging fruitful and productive. Yun po, para sa Pilipinas. Opo.
Yeah, thank you.
Any final questions, comments? It's getting too late there in the US. Questions? None. So I think I would like to take this opportunity to thank everybody, the speakers, and you were able to see a snapshot of the kind of research and our interest in our research cluster number 9, mathematical, statistical, and data science, which is actually an interplay of math, statistics, computing in solving, along with domain experts in solving real life problems and in trying to understand real life phenomenon in various aspects of our lives, whether it's in the biological systems, ecology, economy. They are all within the interest of our research cluster, which is co-chaired by May Lim and myself. So we hope to see you again in our future webinars of PAASE in general and of Rec 9 in particular, because as I noted earlier, May and I will soon discuss the possibility of having a webinar on geospatial data in the country with highlight on NAMRIA. So we will put NAMRIA on the spot so that we will be able to okay, so and of course, Dr. Lansigan, who is part of Rec 9, you should be in our next webinar because I think your interest is much related here. So May, let's take note of that. Dr. Lansigan should be one of our speakers in the next webinar.
Okay, sure.
Ayun, so meron na tayong speaker. Okay. With that, thank you very much, everyone. Good morning and good evening in the US.
Thank
See
you.
you in the future webinars.
Thank you, Ernil, and
Thank you
thank
po.
you, Dr. Lisa and the May Lim, and yeah.
Thank you, May and
And
Perniel.
and
Thank you.
Iris, yeah.
Thank you, sir, Dr. Perniel.
Thank you.
Okay, thanks.